All right, welcome back to Mathematics Tutorials. Today we're going to be talking about the area between two curves. So we've already covered integrals and areas and how that's all connected, but we're going to take that a step further today by doing, like I said, area between two curves. So, of course, the general thing for an integral is, right, area equals the weird thing from A to B, A, of f of x and dx, right? So here, you can see by this formula, what we're actually going to do is we're going to, instead of having f of x dx, we're going to have f of x minus g of x, where f of x is the top function and d of x is, or g of x is the bottom function. So if we look at something like this, right, we're basically creating a new function saying just look at the difference, right? Because it doesn't really matter, right, what these two functions are because we're just looking at the difference between them, right? So this stuff doesn't matter, this stuff doesn't matter, right? We're looking at just this green part. And to get that, we would take, this spot on blue and this spot on red and subtract them, right? This spot on blue, this spot on red, and subtract them. So that's what we're doing here. Now, notice how this could be a lot higher up, right? And it would still be the same, right? Because you're just subtracting. You're just getting the difference from here to here. Now, another thing you want to do is think about how in this formula, right, this fx minus gx, we're kind of generalizing something. We're generalizing the specific case of just finding an area, right? Because if we had a graph like this, and we were trying to find the area of this, right? You can think of just, finding the area, but finding the area of what exactly? Between what? Well, obviously between, A and B, but between the parabola, right, the graph, and the x-axis. So basically, we're finding the area, let's call this f of x. We're finding the area of, from A to B, of f of x between fx and the x-axis. Well, the x-axis is just x or y equals 0. So really, we're doing f of x minus g of x, but g of x is just 0. So we're basically saying f of x minus 0 or just f of x, which makes sense, right? That means that this formula, in a very specific case where g of x is just y equals 0, can be turned into this formula. So that makes sense. Now, what if we wanted to do something like this, right, where we have not the same function on the top the whole time, right? Because clearly here, red's on the top and then blue's on the top. If we tried to do the difference between red and blue, you would end up doing this area, but then this area would be negative, so it'd be like this area minus this area, which is not really what you want. And so really the only way to address this is to split it into two parts. So you would go from, and you would separate it where one crosses over, right, where they're equal. So you would say, let's say this is point B. Let's say this is point A, and this is point C. Let's say the cosine is uh, f of x, and then the sine is g of x, right? The only way to do this is to say, look, the area equals the integral from a to b of the top function minus the bottom. Top function for this area right here is cosine x minus the bottom one. Of course, these parentheses are kind of implied. And then you would have to add, right, the area from b to c. Same functions, but instead of cosine minus sine, we're going to go sine minus cosine, right, because the sine is on top. So it would be sine x minus cosine x dx. And that's how you deal with the two separate ones. So this is a pretty simple concept. It's really not much different from what we have already learned. There are some interesting things you can do with this. For example, like when you start doing derivatives in terms of y or integrals in terms of the y variable, you have something, let's say like this, and you have that, thinking about, okay, what do I have to subtract here, right? Well, this would be like y equals 5. If I want this area, or if I want this area, be like, 5 minus whatever this is, but in y. There's more you can do with this, but honestly, it stays pretty simple. It's basically just which two equations do I subtract and in what order, right? Figuring out which is the top one is the only one that can be difficult sometimes, especially like I said, if you're doing something with the y variable, right? Figuring out that this one's actually on top, right? Because you have to rotate it. Other than that, this isn't too difficult. So this is a pretty short episode, but maybe I'll keep it short. Maybe I'll cover something else. I do want to cover volume. I don't know if I should save that for the next episode or not, but I mean, yeah, I'll save that for the next one. So I'll keep this one very short, um, which is good because, I have stuff to do and this is a pretty simple topic. And this lets me, stretch out these videos for even longer on less actual content. So, all right, well, let me check the book to see if there's anything big I'm missing because, I don't want to actually miss something important, but I think I've already covered everything important for this subject. So, yeah, you can exit the video now if you would like. It's just gonna be me looking for anything I missed. Yep, area between two curves. Horizontal representative rectangle. Yeah, so I guess I'll talk about this. So if they have something like this, where they have a sideways parabola and then a line like this, and they're saying find this area. This is one of those ones where you would want to do it in terms of y, because the only other way would be to, I guess, go from here to here maybe, and then from here to here. But I don't think that really works out all that well. You have to split it into multiple things, and say like this straight line minus this curved part, and then this curved part minus this curved part. I don't know. I think it'd be weird. So instead, you just kind of think of it as being rotated and say, you know, whatever dy, and you just look at, well, you'd have to find the inverses, right? Um, like let's say this is like y equals x, or y equals 2x, and obviously the inverse, right? Uh, y equals 1/2 x, something like that, right? Um, I think that's right. Anyways, and then you would say, what's from here to here? What's from here to here? That's what a subtraction. Um, so that's the whole thing with doing it in terms of y. Of course, I suppose you could just do it in terms of x, but I really think it's just easier to do it in terms of y. Um, boy, that really is basically it as far as this concept goes, which is fine. Sometimes you need simpler stuff. So next time we're going to talk about uh, volume, and my book is calling this the disk method. Uh, is that disk method? Is that really what it's called? Sure. I'll put a question mark because I don't really know. But oh, there's also a washer method. Okay, I don't know. Volume of solid of revolution. All right, that'll be next time. See ya.